Okay, thank you everyone for joining. This is Exploratory's online seminar number 28. Today, I'd like to introduce Exploratory version 6.0, which we released, I think 2 weeks ago or so. This is actually a really important milestone release for us. Let's get started. Just in case if you don't know me, my name is Kan Nishida, CEO, co-founder at Exploratory. We started Exploratory 4 years ago to democratize data science. Prior to that, I used to be working at Oracle as a product development director, leading a team, building the data science products. And also, I was involved in some of the training and education programs to spread more like data science skills throughout the customers at that time. Okay, and then so at the Exploratory, we like to make sure like everyone can use data science. I think this is a great technology and great methods. To do, we call it third wave. Third wave is really about bringing all those advancements and the innovation happening in the open source community to outside without requiring the programming. You can use UI products to be able to do data science. I think that's what we are trying to do. Then when we say the data science workflow, we think this way. So like usually like you have the business questions and then you want to answer. And then you are with the data. So the first thing you want to do, you want to access the data. And then typically, like the data is not ready for visualizing or analyzing it. So you want to do data wrangling, which is really about cleaning the data, transforming the data, preparing the data. Then like you want to use charts or visualization to visualize the data so that your eyes can understand or recognize the patterns in the data. Sometimes that works, but many times that doesn't work because your eyes have limitations. So that's where like you have the analytics. Then you can find, you use analytics algorithms to find the patterns that your eyes can't recognize. Then you go through this process of like going back and forth, any direction, any sequence, until you find the insights. And then once you find the insights, if you are the person making the decision, that's good enough. But most of the time, like you make decision with other stakeholders, such as your partners, coworkers, and customers, and so on. So you need to communicate the insights you found in a clear way. So that's the communication piece. And we think this data access, data wrangling, visualization, analytics, and communication, these 5 components of important piece of data science. And we, as Exploratory, want to make these 5 things, this process of these 5 pieces, as easy and quick as possible by providing a modern and a simple UI. That's really the Exploratory. Okay, enough about myself and enough about Exploratory. So let's get into introduction to Exploratory version 6.0. Okay, so first, this version 6.0 is actually like our 4th year anniversary release. So this is quite a milestone for us. We released version 1.0 4 years ago in May. And at the time, like when we released, it was basically we wanted to create a UI on top of R, which is the data science programming language. So therefore, like the initial experience was UI, but at the same time, like you had to type the command. And we thought being able to type the command, but along with these charts automatically generated itself is great. But obviously, you had to know which command to use, how to use. So that was a challenge. So we added some like a command suggestion, that kind of stuff, but still it was pretty rough at the beginning 4 years ago. So this was like initial Exploratory. And then we got into version 2.0, and that's when we kind of switched to more UI way. So we started something called a token at the top. And then basically, instead of like typing the command, you can actually choose from the selection list to do the data wrangling. And then the version 3.0, this is about like 2 years ago and also, no, sorry, 3 years ago. So we started adding more like analytic capability. But though at that time, like analytics is something that like you have to create a step at the right-hand side, which is even today we have the right-hand side where you add data wrangling step, but even the analytics, you had to add those steps to create the analytics. And then 2017, August, this is about 3 years ago, actually. This is 4.0. This is when we added the analytics view. So when you go to the analytics view, now like you can just select the charts and click the button to get the set of visualization that explains what is happening with the model. So this is kind of a first attempt. And then we started incrementally updating the other UI as well. But still around this time, we had this like a token oriented UI. Then version 5.0, this is 2018, October. It's about like 1 year and a half ago. So this is where get into what you see with Exploratory today. So this is kind of like a new paradigm for us. Now, like we got rid of those command token at the top. We focus on, the data wrangling stuff is only at the right-hand side, and then we give more space for charts and analytics and then other views at the center. So this is kind of like a beginning of our sort of a new paradigm with Exploratory. And on top of this 5.0, so we started adding more innovations and the new features and stuff. So like we had the 5.1, 2, 3, 4, 5. The latest before the version 6.0 was 5.5, which I think we released beginning of this year. So then the 6.0 finally. So when we started working on version 6.0, we start thinking like, what should we do? What is that this release means? And then we went back to our mission, which is to democratize data science. And we thought through what the data science was, and we learned a lot over the last 4 years. And the more we think about it, it's really data science is about data analysis, analyzing the data so that you can make better decisions based on the insights. And then what the data analysis is really, we think, is an exploratory data analysis. Data analysis is about like depends on like what type of questions or assumption you can sort of build. And then those questions and assumptions are not necessarily coming from your intuition or experience. Those can come from the data. So you have the data, then you start building assumptions and questions by looking at the data, finding something from the data. Then based on the assumptions and the questions, then your data analysis can be can be great or it can be not. So the exploratory data analysis is sort of like, people tend to think this is a kind of a pre-step before getting to the real data analysis. But we think this is really at the beginning and the middle, at the end. It's always this sort of like attitude towards the data analysis. And coincidentally or intentionally, we actually, our product is called Exploratory. Our company is called Exploratory. So like for us, Exploratory is something, our soul of our, everyday thing we do. So that now, exploratory data analysis, or we call it EDA, is exploratory and iterative process of asking many questions and find answers from data in order to build better hypotheses for explanation and prediction and control. I think this second part in the board is really important. Then this exploratory data analysis is not something that we created. This was published, this book was published in the 70s by John Tukey. So it's been like 50 years ago. So it's been, it's an old thing. And according to, this is his quote, some of you guys, you might have already known, is far better an approximate answer to the right question, which is often vague, than an exact answer to the wrong question, which can always be made precise. So it's really, I think like EDA is about, what are the questions you ask, or what type of the questions you come up with from even doing a data analysis. I think the question part is really important. Then, now there are two principal questions for EDA. The first one is how the variation in variables. And the second one is how are the variables associated or correlated to one another. These two questions sounds technical, but I think it's more you think about it, it's really the key questions to ask when you start working with the data, when you start analyzing the data. And then if you focus on these two things, you can actually gain a lot of insights without getting distracted by many things that you might find from the data. So these are the two things that you want to always think about, like kind of sticking with it. Then the variation is really, data varies, like never be like only one single value. Even your sales data, your conversion data, page view data, or whatever you have, the data always vary. So that's the variation. So the question is how the data varies, how, what makes go high or go low kind of stuff. And then the next question is about association and correlation, right? So how data are related, things are related in your data. So this is about a relationship where changes in one variable happen together with changes in another variable with a certain rule. And association correlation, sometimes we mix it, sometimes we separate. It's not that big of a deal to me, personally, but if you want to go precise, associations tend to be more something involved in a categorical variable. So any type of the relationship between two variables, it's very more relaxed concept. Where correlation is a little more strict, a certain type of association between two continuous variables. So association, for example, think of it like we have employee data, and then it's about like how much this employee making. There may be like some people making $5,000 a month or $2,000 a month or something. Then if you bring the country data, let's say like United States, employee in the United States maybe make around 5,000, or UK is a little lower. So seems like when the country change, the monthly income also, the range change, the variation change. So this type of relationship is called association. Where correlation is continuous. So like age as an x-axis, monthly income as a y-axis. And these two are continuous or more numerical, more precisely in this case. So the age increase, then the monthly income increase. If you find this type of relationship, and then that's correlation, and that's a great insight itself. So we have like exploratory, when you import the data, the first thing you see is this summary view. This summary view is to help you find or understand how the variation of each variable. So for example, age, the minimum day age is 18 to 60 years old. And then, maybe somewhere around like 20 or 30 years old, there are, more people than other age range, and so on. And this is basically, we had this from version 1.0, 4 years ago. And we haven't, we made incremental changes and improvement and so on, but this summary view hasn't progressed much. And in version 6.0, that's where we focus. So we added this highlight and correlate buttons. And these to help the second question, even like the little bit about like first question too, but like really focus on this like a second questions. How are the variables associated or correlated to one another? So when you click on the highlight or correlate button, you get into highlight mode or correlate mode. In the highlight mode, you want to select, you can create a condition. So for example, this data is about employee data, and there's a monthly income column. Then like, you can create, let's say, like, create a condition of like greater than $5,000 or something. Then when you click on run button, then you can find the data that matches with the condition, where that data is. For example, by looking at this, like, let's say the business travel, which is a column at the top, and then you see like a lot of people who are making more than or greater than $5,000 in this travel rarely. Like this is business travel rarely means like people don't really go business travel much. And also right-hand side top, there is a kind of a toggle, so between a count and the percent ratio. So you can click on the percent ratio to see the percentage of those people who matches with the condition. Excuse me. And there's many variation of this condition. So not just a numeric, but you can create, maybe categorical, let's say department equals something or not equal something. And also like you can select outlier as well. I'm gonna talk about that a little bit later about this outlier. And another one is, so I talked about the highlight, and then another one is a correlate. And this correlate feature is you select the column, in this case, again, let's select the monthly income, and then click on run button. You don't actually have to click on run button, you just select the monthly income column. Then automatically do a lot of calculation behind the scene, and then come up with the error bar. Error bar is about like showing the average at the center, which is a dot. And then the bar, you can switch between, but the default is 95% confidence interval. So if you take like a sample like 100 times, probably, and then the real average should reside within this range. That's really the very, very high level of explaining 95% confidence interval. This interval is really gets shorter when you have a lot of data there. If you don't have a lot of data, in this case, a lot of employee in that particular section, then that confidence interval get to tend to be longer. So that also indicates, like how much you can trust or you can be confident with that average values. But nonetheless, by looking at this error bar, you can see if there's a correlation or association between the two variables. So the visual helps you find or understand the relationship between two variables, any given variable, two pair of the variables. And also, when you have logical, I think this slide is something wrong, but at the top is monthly income, which is numerical. You can actually select the logical variable or the column as well. Logical is the true or false. It's kind of like a categorical, but it's very special case. Then the y-axis is, instead of like average of the monthly income, this case is like a percentage of true. So like, let's say like left-hand side, you see the age, and then like younger age has a high percentage, let's say like 50% or something of attrition. That means higher chance of leaving a company when you are younger age. And then you can click on this chart icon, and then that will create the error bar chart automatically. So you don't have to do like a lot of different settings. You can start with error bar right away. And also these metrics underneath. So in this case, I selected attrition, which is a logical data type, as a target variable. Then you see like AUC, p-value, and so on. When you click on these, and it depends which you click. In this case, p-value is chi-square test. So in case you know the statistical test, it will create a chi-square test under the analytics view automatically. Or like if you click on AUC bracket logistic, and then it will create a logistic regression model automatically under the analytics view. So having said that, I'm going to just go quickly to show a quick demo about this piece. I think it's more like interactive is better. So here I have the employee data, age, and the attrition means if this employee has left or not. Let me just go to the table view quickly. So each row is each employee. And then about like there are 27 attributes about this employee. How much they're making, the male, female, what's the job level, and so on. And then first, let's say like I want to find, let's say like about maybe like there's a job role here, and then I want to find like a particular job type people in this data. So I can click on highlight. And then let's say job role is maybe like a sales representative. So where are these people? And I can click on it. I can see like 83 out of 1,470. So these 83 people, for example, in the age, it resides in this light blue. So which is like super young, not super, I don't know, between 18 to 22 years old. They are about like 30% of this range are actually sales representative. And the right-hand side top, you can toggle if you want to see just a count or you want to see that ratio. I would recommend ratio because it's easier to compare among different categories. But you can switch between. And then also, like for example, here, I'm looking at the sales representative. Oh, by the way, here is like a department in the sales department, which is kind of makes sense. 20% of the people sales representative. I think there was like another type like sales executive. So maybe that the rest, which is 80%, can be a different role. And then the gender, for example, like male or female, it's pretty much the same amount. So not much difference. Education field though, for example, sales rep tend to have higher like, in the marketing or technical degree and so on. And then here, the highlight, you can create, for example, age. Let's say like you want to find like greater than 50 years old or less than 20 years old. Or another thing you can do is, let's say like monthly income. And then I want to find the outlier. Outlier is some more like extreme values. So the people who are making too much money or too less money or something. So like I can select the is outlier. And then you have the couple options. I'm going to go with the default IQR. And then you want to find like an upper, like a too much money making people. And then in that case, I can just go with upper. Or I can go with boss, either way. So like, let's find like the people who are making a lot of money in this company. And then obviously that those are tend to be higher age. And then those we can find like a lot in the human resource. Job level tend to be higher. And then job role seems like a manager. So these are the insights you can get from the highlight very quickly. So now let's take a look at the, this correlate. So let's say like we're interested in monthly income, like here, and the monthly income ranges from $1,000 to $20,000. This is monthly income, so like $20,000 is a lot of money. So, but there's huge variation here. And then I want to understand like what makes these differences. So that's where like you want to go to the correlate. And the first thing you want to do is select the column. Then it automatically calculate a lot of things. First thing is basically calculate this information to draw this error bar. And the error bar chart, again, at the center, it's kind of hard to see because of the, oh, here. The center is the average in this case, because we call it target variable here. The monthly income is a numerical. So it's basically, when you see here, the mean, 4,787, that's the average of the yes people in attrition. And then the default is 95% confidence interval. So we can say this ranges from 4,300 to 5,200. Within this range, most likely the average, the real average resides. So the average, depends. Like you happen to have like this 100 people, and then you get the average. But if you happen to have like a slightly different 100 people, the average can easily change. So then like how much you can trust this average number. So in that case, typically like you use 95% or 99%, whatever that is, but a confidence interval. So that's what that really means. Then besides that, like a complicated concept, but just focus on even the average, the age, the age increase, the higher the age, the higher the monthly income. And then to the point, I think around here is sort of like, it's almost like a linear ish relationship. Then after that, that goes down. But this is average. So, like there are a lot of variation to it, but gives you a hint or signal of like what type of relationship it has. For example, here, let's say like job involvement. And the job involvement, let's say a score from 1 to 4. And it seems like even like an increase, that doesn't mean that salary or like monthly income increase. It's almost like kind of flat. And then with this 95% in, confidence interval, there's not much difference between 1, 2, 3, 4, among 1, 2, 3, 4. So that means maybe like that this job involvement is not something that we can use to estimate or predict how much each employee is making. So by looking at this chart, we can understand certain relationship. And the cool thing here is one, when you click on this chart button, then you can create the error bar chart. That's that I already shown the slide. Another thing is here, R squared bracket linear. This means if I click on this one, this will create the linear regression model under the analytics view. What I want to do before going there is there's a sort parameter. And under the sort, I can actually sort this column based on this R square or correlation or p-value. Correlation is actually easier concept because correlation scores ranging from -1 to 1. -1 is the strongest negative correlation, which means one variable increase, the other variable decrease, that type of the relationship. And then the correlation 1 means the strongest positive correlation. That means one variable increase, then the other variable also increase. How much is a different story, but that's the positive correlation. Then I can actually sort by the correlation. But the problem of sorting by the correlation is now sorting from the +1 to -1. In this case, there's no minus correlation. Oh, oops. Wait, here. There's no, here it goes, minus 0.02. There's not much crazy minus value. But so this is one way to sort, but one problem is from positive to negative. So like, if you want to know like what are the strong correlation regardless of negative or positive, then you might get kind of confused a little bit. Another thing is that there's no correlation metric that can be used for categorical variable. So therefore, you don't know, for example, this attrition is, even like attrition looks like there's a good association there, but it doesn't come in the front. So that's where this R square can be more useful. R square indicates that how much this model, which is a linear regression model being built behind the scene, can explain, actually, let's forget about linear regression. Let's, this R square, in a simple way to explain is how much of the variance in the monthly income can be explained by the job level or job role, or like each variable. So for example, when you see 0.90 R squared, that means the variance of the monthly income can be 90% of the variance of the monthly income can be explained by the job level, which means here, when the job level moves up to from 1 to 2, 2 to 3, looks like monthly income increase dramatically, and then that difference is pretty outstanding. So that means higher the R squared, very similar to correlation, but higher the R squared signals the strongest strengths of the correlation. So from job level, job roles, total working years, age, so it seems like these variables has higher R squared. That means they can explain why. I'm not sure like why is a good word to use here, but how the monthly income change. Okay, so that says if I click on this R squared linear button, then it will create a linear regression model and an analytics view. Then you can do a lot of things. You can go to different tabs, but the first thing I want to do is usually if I have the job level, this is like a simple linear regression model, but I can bring in like other variables. Let's say seems like a job role, and also maybe like an age, and also what did we have? Maybe I thought there's a total working years. Those are like 4 variables sorted at the top. So I'm going to select all of them and click run button. Then like we just did the multiple linear regression model that we just created. Then we can check like what's the summary scores, what's the prediction, what's the importance, and so on. This area is something that I'm gonna talk about a little bit later, but we have the prediction tab, which is basically like how the monthly income change based when the job level change. Same thing for the job role, how the monthly income change when the job role change. And those information is something that you can see under the prediction tab. And then when you go to the importance tab, which you can see like which variables are more important to predict the monthly income. In other words, which variables are more correlated to monthly income compared to others. So in this here, we can tell the job level is significantly more important than the others. And then job roles are next. And the total working years a little bit, and age is almost like none. So we can say, we can guess like a job level and a job role are the 2 sort of like a big factors that you know, like impacting on the monthly income is either it goes higher or lower, and so on. Okay, so now, and then we have like a p-value, which is a statistical significance test. Is a hypothesis test is going on. And this p-value is using Kruskal-Wallis test. And the reason we chose Kruskal-Wallis is because it has less assumption. So there are many statistical tests, like let's say a t-test or other stuff, but Kruskal-Wallis doesn't assume the original distribution to be in a normal distribution or anything like that. So it's easier to use. So we have this Kruskal-Wallis. Same thing, if you click on this, then it will create the Kruskal-Wallis test under the analytics view. And so then you can find more information there as well. Okay. So that's the very quick introduction of this Correlate view. And then you can, this release, we support numerical and logical. Here, this data is not logical. For example, the attrition is not logical. It's like a yes or no. And this can be easily converted to logical by selecting change data type and then convert to logical and just click run button. And the default, yes becomes true, no becomes false. You can change that inside this function. But once you convert it, then like, you go to the Correlate mode, and then like, you can select the column to attrition column. Then you can see that's basically a similar view. Here though, y-axis is the percentage. So note that this doesn't represent the average or anything like that because this is true or false. So whenever like you see here, for example, this is like a travel frequently employee have the probability or a percentage of 24% of the people who have left the company. And then here, slightly different from the numerical. So like it's AUC logistic and then p-value chi-square. I'm planning to do exploratory data analysis seminar, maybe like in a few weeks. So that's when I'm gonna talk more into detail about these features. Okay, so that's all for the summary view. And then let's get to other areas. So data wrangling and then the chart and then also analytics. And then let me see, we have 20 more minutes, okay. So table view, we added the filter. And this filter is pretty convenient because you can create a filter at the right-hand side data wrangling step or from the column header menu that you could do before, even before. But sometimes, especially when you're working with a data wrangling, like cleaning up the data or something, like you just want to find what happened to that data, like maybe like, you know, is there data starting with a Google or a certain like a text, then like you want to do you know, transformation or cleaning up or something like that. So in that case, it's sort of like instant kind of filter capability. Then you know, like once you decide like, okay, this is something I really need as part of like a sort of like official wrangling step, then you want to create that filter step separately. But this is to give you a quick and instant capability of the filtering the data that you see only in the table view. Okay. Then you can disable it. So you can enable, disable, and see like, you know, whatever the operation you're doing is working the way you expect. You can check quickly. And the outliers I was talking about a little bit as part of the summary view. When you have the data, something like this, this is the price data of all the properties on the Airbnb in New York City. And then because of the extreme values, you can't really see like the real movement of the data. Then typically what you can do is you want to get rid of the outlier and see like what the distributions are. Then you can click, in this case, the chart level filter, and then select that no outlier option. And then same thing, like I show, select the outlier detection method, and then you can get rid of it. Or you can focus on just the outlier, either way. And then you can use that as a highlight, and also you can use that in a table filter that we just talked about. Also, another thing we did in the data wrangling is to support window calculation for date column. This one was there for the numerical columns, and now we just added for the date and the project city. Project city is the date and time data types. Okay, so now the chart, a couple things. First is a map. Is pretty cool. Like we added this map standard type. Used to be map area, map longitude, latitude, but we added this like map standard to make it easier to map that column. So for example, this is like a world country map, and then world country sometimes comes with a country name, even the country name, United States, US, you know, different variations. And sometimes you have like an ISO 2 code or 3. It can be a variety of the names. So to make it more like easier to automatically like do the fuzzy mapping, we created the standard map. So that means either you select ISO code or country name, you know, what have you. I mean, like, you know, most of the stuff should work. If something like you find doesn't work, let us know. Then another thing is we did is when you import that data and then you try to visualize, what happened often is something like this. Like this is like a COVID-19 data, and I try to see like the number of the deaths by the countries. And what happens is it happened to have like 188 countries data. So therefore, there's so many lines. And then sometimes you want to focus on just like a top 20. And depends which, what do you mean by top 20? Top 20 in the total, top 20 at the last value. So we added this like limit setting for the color. Then you can select those things as well. So, and also, I'd like to show that part very, very quickly. Here I have this like a COVID data. And then like if I go, and then like a number of the countries is like 188 countries. Okay. And then like if I go here and then let's say like a line chart and assign the data as x-axis, let's see by the day, and the y-axis to be maybe like a number of the cases, and then you get this chart. But I want to see by the country, so like if I assign a country data, and then the default is like 20 countries plus others, because 188, that's too much. If I take this other countries, other group setting, then you're gonna see 188 countries, and then like you kind of get too much, because most of the countries are very low numbers anyway. And that's where like you wanna use this limit feature. By selecting this limit, and then you can either like create a condition, let's say like a greater than 10 or greater than 100, or you can use top, maybe like a top 20. Let's do top 20. And the current Y1 count is fine, like this is like because we are caring about the number of the cases, or you can just select the different columns as well. And then let's say instead of like a sum meaning the total numbers, I want to see that at the last value, this value right here, I want to see like a top 20 based on the last value of each country. Then I can select here the last row, if assuming this the data is sorted already in the data. Then I can click on the apply button. Then now like we have only 20 based on the numbers displayed at the most right-hand side. So, this one is I use the last, but you can use different functions as well. So this is limit values. Other thing is we support multiple reference line. This is also convenient, especially when you have like time series or type of data. You might want to say like, hey, this happened this day, that happened this day or something. Then we support this a constant value for now. And then like you want to do is like if it's a time axis, then you want to put like a time information as a constant value. You can put the label and so on as well. And analytics. This is also, we went back to drawing board before we start version 6.0. Really how to democratize the data science is about, you can use analytics, you can build a prediction model. The challenge is how to understand what the model is saying. So the model interpretability is, for us, I think it's a really important problem. And then we've also enhance the survival analysis area as well. So model interpretability is about how are the variables associated or correlated to one another. This thing is really important for exploratory data analysis as well. And the building the prediction models, you have the data, you apply the algorithms, and the algorithm build a prediction model. And then you have the new data, and then give that new data to the model predict based on the patterns that it finds in the original data. So that means that this algorithm has learned the patterns inside the data. And then based on the pattern, it builds a model. And then the patterns we're talking about here is really the relationship among the variables. And then it predicts based on that relationship. So the interpreting prediction model is about understanding that relationship in data. And then one of the challenges of interpreting the models is because they're a mix of the statistical learning and machine learning, and even like machine learning or even like statistical learning, there are a bit of the variations. So you get like different type of information sometimes, or you have different type of insights sometimes, but they're really about finding a relationship in the data. And then, if that's the case, can we have at least a common framework to understand the relationships that model found in an effective way or even more intuitive way? And that is the analytics grammar and a common framework for understanding what the models found. And the analytics grammar we define here is variable importance, prediction by variables, model quality, and the predicted data. And let's take a look at this variable importance and prediction by variance. Variable importance is which variables are more correlated or associated with our target variable. Then we basically do here is we actually use some method called permutation importance. And permutation importance is about, I'm gonna use this example. Here's the Beatles. I hope you guys know this band. It's an old band. But let's say who are more important in this band, right? So, and then to test, so permutation importance way is to build a model without one given variable. Okay, so let's say if I remove this guy, John Lennon, from the Beatles and have them perform, and how the performance is, we evaluate the performance and compared to the time like all of them are there. So this is the base performance. And then when we compare with this just 3 people without John Lennon, and how much the performance decrease, and then that is the score of the importance of the John Lennon. Doing the same thing for each person, like let's say Ringo Starr, like without that person, then we ask them to perform and how the performance decrease. And we do that for each person. And then each time like the performance should decrease compared to all of them are there. And then that decrease is the indicator of how important that particular person is. And instead of the person, like we actually use the variables. And then like we get this. So this is great because then like, we don't have to worry about this like a statistical algorithm or machine learning algorithm or which algorithm, that type of things. We purely focus on the predictive capability, prediction side of things. So with that, we can do and apply the same technique for the linear regression, GLM. GLM have a few of them, a few different types. One of them, the Poisson or logistic regression, and then also machine learning side, a decision tree, random forest, and so on. Only the random forest though, like using the same technique, but also it uses some method called Boruta, which basically build a 20 random forest models because random forest, as the name suggests, it takes the random sample and then build a tree and then build like 20 or 100 trees behind the scene. So therefore depends like which random sample it takes from the original data, that even this importance score varies. And then you get confused sometimes like this, like over time variable is number 1, then total working year is number 2. Next time you run it, and then total working year is number 1, over time number 3 or something like that. So we run random forest 20 times behind the scene, build a model 20 times, and then show the importance scores in the box chart or in a distribution variation way. Then you can kind of compare. Anyway, for more details, you might want to take a look at Random Forest online seminar I did probably like 6 months ago. So, okay. And then also survival analysis side, Cox regression has the same thing, the importance tab. Then you see like which variables are more important to predict the survival curve or survival rate. And we added a random survival forest in this release, which is a machine learning version of Cox regression or like a survival prediction model. So even there, we have this importance tab. And another one is a prediction by variables. And it used to be called, we called it like effects by variables, but we made it simple to call it the prediction. And this is about like, for example, left-hand side top, the job level. So like when the job level change, how the monthly income change. And the same thing for the job role, when the job role change, how the monthly income change. And also this chart is that when you understand, like when the other variable stays constant, and only the job role change and how much of the monthly income change. And then the blue line or dots are the predicted values based on this, in this case, a linear regression model. Gray is, in this case, the average and of the actual values. So this model tried to fit on the actual values, but when you start adding more variables, you start seeing like more gap between the gray and the blue. That's because this one is showing only the job role. Let's say, like, let's focus on job role. Only the job role change, and then how the monthly income change. When total working years, the job level, the age, they don't, they don't change. They stay the same. So you can see like sort of independent, isolated effect of each variable. And so you can not only you can see how that's monthly income change, but also how much of the power that each variable has, or effect that each variable has on the monthly income change. So, so this is linear regression. Same thing for all other models. Logistic regression, decision tree, random forest. So regardless statistical or machine learning model, you have the same view. And even the survival analysis, the Cox regression, random survival forest, you have the same, this prediction view. Cox regression, random survival forest, the way they predict is like you set like what years, what period, let's say in this case, in 6 years, what's the percent rate, what's the probability of people leaving the company or canceling the service or something like that. So in this case, default is the median value happened to be 6 year in this case. And then like you can say the people who work overtime is higher, and about like 0.3 or 0.2, 20% chance of like leaving in a 6 years period. Okay, so that's the common framework for all the prediction model under the analytics view. And then the survival prediction model. We have a little bit of time, so I'm going to just try to cover it quickly. But I'm planning to do another session focusing on the survival analysis area. But in a nutshell, the Cox regression, cool thing about survival analysis, like we added this like a survival curves tab. So under there, you can see how the survival curve change when each variable, predictor variable change. For example, when the job role change, how the survival curve would be. The survival curve is like x-axis the time, and then the y-axis is the survival rate or retention rate, or how much people who's, what's the probability people still survive or stay. And then, for example, the next one, the overtime, like when the overtime is yes or no, and how the survival curve change. So this is a Cox regression. And then here is a random survival forest. It has that survival curve tab as well. And you see different insights, or like different, for example, you just look at this survival curves between the Cox regression and then random forest are different. And that is because the Cox regression model is a statistical side of running model. So therefore, it has a constant constraint. And the constraint, the linear regression constraint is like the constant slope is the constant. It's like doesn't change regardless of the x-axis or predictive values. And the same thing, the logistic regression. Logistic regression is like odds ratio is the constant. It never changes. And the same thing, the Cox regression model is the hazard ratio is a constant. So therefore, if the actual data doesn't have such constant, rarely in the real world, we don't have such data. So it's not good at capturing that type of the patterns or relationship that changes over time. But because of the constant, it's easier to explain. And also it sort of like one of the point of the building the model is to simplify what's happening in the real world. So like it's in a sense, like this statistical model can be still useful. However, when you use a machine learning model, it can capture The left-hand side is actual data, and it can capture the relationship is really happening in the actual data better. Because it doesn't have such constraint. There's nothing, it's more like if else, so like a series of if else. So if you, 10 years, 20 years, 30 years, and it's somehow like the survival curve change or the slope change, random forest can capture those information. However, there's a risk of overfitting. So it might miss the general patterns instead of like some kind of micro thing. It might be focusing too much. So that's maybe like another topic. It's too much for this session, but there's a difference between machine learning and a statistical learning model. So it's good to run those two and then compare these two and then learn from the difference. So so that's that. And the last part is we did something for the data access piece. So the one is weather data, and another one is schedule for extension data. So weather, like you go to extension data, and then you can actually import the weather data. And this one was there, but we made it easier to select the country network. So like it's Japan, United States, United Kingdom, and so on. And then also select like a, the prefectures or states and so on. So it's all dropped down, so it's easier to select. Also, we support scheduling for these extensions. This one is actually, the red circle is wrong. We support quando and stock price and weather. We don't support RSS data because it seems like nobody's really using it. The quando and the stock price are about financial data. And the weather is something that we saw. So you can create, you can download, create a chart, publish to our server, Exploratory.io, and then you can schedule those data so you can see, for example, Apple stock every day and so on. Okay, so that's the main things. And then here, there's a release note, and then there are many enhancements and bug fixes. And also, we released 6.0.1, which is a patch to 6.0. And that has many bug fixes and some of the enhancements as well. So I recommend you take a look at release notes. And I strongly recommend, if you haven't done so, download the latest version, which is 6.0.1 from our download page. If you are the personal or business edition or community edition, then you want to go to the exploratory.io/download. If you are the public edition user, then you want to go to download-public. You don't have to remember this URL. You can go to our website, and then this is like a download, and then either desktop or public. If you are, again, personal, business, or community version, you want to use desktop. And then you're the public version, you want to go to public. And even like if you happen to be just sign up in the last 30 days or so, but you want to actually try Exploratory in a private environment instead of a public environment and sharing all the data to the outside, then there's a 30 days free trial. If you want to extend the trial period, please ask us. We can extend that as well. And then you can use this Exploratory desktop version. Okay, that's pretty much it. And the next seminar is next week. I'm going to resume the data visualization workshop. We were doing that like over the last few weeks until 2 weeks ago. So we're going to resume. And this is about visualizing uncertainty, sorry. And then I'm going to talk about error bar chart that we saw in the summary view. I'm going to go more in detail into the confidence interval and so on. Okay, that's it. And I'm going to stop here.